disconnect. It's got three 30 amp fuses in it. Circuit breakers for spare parts. Sometimes they put fuses in. This is a GFCI. It's basically there for laptops, and it's used to protect other equipment that requires a GFCI. Control transformer. These are your two programmable relays. Distribution box. Wait till that's done. Alright. Why do I tell you this is a distribution box? We never know what those wonderful people in St. Paul or Washington, D.C. are going to dream of next. And let's hypothetically say they tell you need to add some E-jaw that's not been invented yet to your machine. And it requires 120 volt power to operate. Well, the 2s are neutral wires, the 3s and 4s are hot all the time, the number 6s are what the controls use. Notice how they spec in spare terminal blocks. Notice how they spec in extra terminal connections down here. What's that for? For that hypothetical E-jaw that hasn't been invented yet. You want to be able to have it, you don't want to have to buy another control panel. Boom, slap it on the DIN rail, wire it in, stick it in there, go. Punch another hole in the bottom to run it into the conduit, you're ready to rock and roll. There's also unused inputs and outputs on one of these programmable relays. That way if you got something you got to add on, like a perfume poofer, let's say they invent that to make things smell better, boom, you got what's there. These are your control relays. If you wanted to simulate a fault, you take your fingernail, lift that up. Let's see what fault that activates, and it says screen 2 fault. Want to deactivate it, you push that back down, hit the reset button, then it goes back. This is for your soft starts that go to the screens. They use soft starts because they have a lot of torque requirement to get going, and they don't want them to start and stop with a big jerk. When the screen comes up, that motor's working hard. It comes past the point where it's going to start going downhill. It actually acts like a generator for a little bit, and then it comes back down. If you wanted to see what the amperage looks like as it's operating, there's my amp probe. It vacillates on and up. When it's going on the uphill, it's drawing your amperage. When it's going down, it's actually producing the amperage and sending it back into the grid. But the nice thing about it, you guys have so many other big electric motors running around here. Anything you get from generation is going to be essentially wiped out, not be a problem. Transformer isolation barrier relays that go to your Parkson system. We had a case where this light was flashing all the time. Solution was to switch the 2 leads because it's got polarity requirements. This is the device used to set your level. We still have a problem with a parameter in there because the screen is running continuously, not cycling it on and off. These are your current monitors. The way you set a current monitor for the screen is you put it in the 10 o'clock position, You bring it down till the fault light just comes on, you bring it up about a notch. You bring it up a notch because you've got the oscillation of your current draw coming when it's going up and downhill, and you don't want any premature tripping. And then when you're done, put it back down to 9 o'clock, so if you get a mechanical jam, it's going to trip it out and do it. This is your primary load protection device. The secondary is built into the soft start. Your tertiary protection is here, and the level 4 protection are these fuses. You blow a fuse, you got a big problem. You trip a circuit breaker, you got a big problem. Circuit breakers for the screens are here. These are for the press and the conveyor.
When you trip out on that bottom overload, or that one that you set the sensitivity on,
Yeah.
do you need to do that loaded?
Just do it with it running.
Okay.
Do it with it's running. I will put it down to the point where it trips and shuts down. Boom, it just shut itself off. I'm
So
gonna
now you just reset the panel door again? Or
Yep.
no?
Just hit the button on the door.
Got it.
Now, some plants have the policy that operators can push this reset button without a problem. That way, if you get a glitch, you got a loss of one phase coming into the plant, you just go around pushing reset buttons on the various equipment, things are up and running again, and boom, you're back in business. Some plants say if you got to open this panel up, you get an electrician involved. It's a good idea to have somebody with some mechanical expertise check things out if this has to be reset. When we get into the wash press, this is the one device I'm going to tell you will have to be reset when it discharges the plug. Because I'll be here, it's going to be running dry, I'm going to give it a wild guess, but what you're going to do with the wash press is you're going to run it until the fault light comes on, boom, it's going to come on, you're going to bump it up 2 notches, hit the reset button. Because that wash press, it builds up torque, the conveyor builds up torque, the wash press and the conveyor get bumped up 2 full notches. That way, if that hypothetical carp commits suicide and gets into the press, you just laugh about it when you see it in the dumpster. You're not out at 2 o'clock in the morning trying to unjam the machine because the carp got in there, or the possum, or the raccoon, or the rat, or whatever else you're talking about. So that's why they have it. They're basically to protect the machine from overtorque. These are your motor starters. These are your overload relays. If you have to come in here and push the reset button on one of those, you better have somebody with electrical expertise go in and check for loose connections and things like that. Make sure you got a problem. If you ever have a problem with a motor and you want to avert any arguments from the motor manufacturer, you disconnect these wires from the terminal block and tag them so they go back in the right place if they don't have tags on them now. You get a megger tester and you megger test it from the panel with it disconnected. If you megger a soft start, you're going to cook it. Some of these overload relays may have delicate electronic equipment in there that may be damaged too, so it's always a good idea to disconnect from the terminal block. Megger test it. If you've got a failure, the next thing you do is take the wires off the connection box of the motor and megger test the motor at the motor. The pecker has the other name, but some people don't like to say that. There's other names for those flex conduits, we don't want to say that either. You got those rubber hoses, those are great, I love them. Anyway, you check it out there, and if it passes the test, it's got some problem like water in the conduits. I've had problems where we've had water in the conduits, and you tell them, well, get the water out of the conduits and seal them up so they don't get wet again. I had this job in Trenton, Illinois, where they had all kinds of problems with their press, tripping out all the time, giving fits, and they didn't tell the electrical contractor to change the PVC pipe to rigid pipe inside concrete above ground. So he did the transition above ground in open air. Every one of those connections cracked. So they had rain, they had snow, we all had a lot of rain, and the conduits filled up with water. Caused some problems. But water in conduits is a big issue. It does happen. Megger tester's a great investment.
We've got a lot of that going on at this plant.
And
Water and conduit outside.
now, when they get all done hooking up these proc sensor wires, it'd be a good idea to seal this conduit with some duct seal or silicone.
From coming in the bad air coming back through.
Right, and the other thing I told John is use some of those gel type wire nuts or print connectors to make sure you don't get a corrosion on that, because it's low voltage. If it's not 120 volts, you're going to end up having a problem eventually. You don't want that headache. Again, if it fails, the screen will just kind of run it and run it and run it because it's not doing it. But I know it's getting a process because I hear the relay clicking and I can see the key light flash on and off up here. So it's not messing up. I guess the next thing we're going to do, these are circuit breakers for the press and conveyor. We can walk around the running step screen, and then I'm going to break off and get a hold of the panel builder and find out which parameters messed up inside there.
Can you briefly go over the door, the front of the panel?
All right. I got a call this last week. Somebody did that, and they tried pulling it out, and they didn't give it a twist. That's a new requirement they're putting on a lot of the panels. You got the twist lock reset, so somebody doesn't do it on there. You've got your screen 1, screen 2, grit flush, conveyor, press zone flush, press zone off, hour meters for the screens and the press. There's your reset button. Now I'll show you something else. When you get everything all hooked up, if you hold this reset button down for 5 seconds, it's going to start everything in auto cycle. It'll start the press, the conveyor, screens, all that stuff. Anything in auto will do that. But right now, because it thinks it's seeing a high level because something's wrong with one of the parameters inside that little box, it's telling it you got a high level and it's running all the time. And I guess what your system integrator is going to do, he's going to snag into the 4 to 20 milliamp signal coming out of that level controller and send it to your SCADA system so you can monitor your level in the channel from SCADA and also issue your high-level alarms to the SCADA rather than use dry contacts. That's what he wants to do. Have we got any other questions? All right. I guess we're going to go out there and work and take a look and go from there.